So we left off on the last screencast with a comparison of various countries, including the countries of Europe, with the United States. And we looked at the various reasons why European countries have higher fuel efficiency than the United States, including government action to impose taxes so that people would be encouraged to buy more fuel-efficient cars. The building of infrastructure for public transportation was huge in Europe, and so that ease of public transportation, which was encouraged, led to more efficiency. In the United States, our government policies favored the building of roads, which encouraged more urban sprawl and more vehicle gasoline. Use of gasoline. But on the flip side, one thing that Europe did not do that the United States has done is they use diesel fuel and allow for higher air pollutants, higher levels of air pollutants to be released into the atmosphere. In the United States, we have very stringent regulations for our vehicles and what they can put into the air, and that does lower fuel efficiency a little bit, but hopefully we could still find a way to find a happy balance here. Okay, so that is it for the use of energy for transportation. Now we're going to look at electricity. Electricity is called a secondary energy source because it's converted from a primary energy source. And the source could be a fossil fuel such as coal or natural gas. It could be a non-renewable source such as nuclear fuel, and it could be a renewable source such as wind or hydroelectricity. Or water power. So all of these primary sources can be converted into a secondary energy source, electricity, which has been very useful, and we have a high demand for it in the United States. Generally speaking, in the United States, about 40% of the energy that we use is used to generate electricity. It's convenient to store and transport. Unfortunately, there are a lot of conversion losses, so a lot of less useful forms of energy that make it to the end user. Now, in New England, we have been able to decrease the percent of electricity that we use as part of our energy profile. And in fact, in New England, during the last, from the 1990s to today, we have now reduced our use of electricity down to making it only 17% of our energy profile, which is a very good reduction. We have also reduced the amount of coal that we are using in New England to generate electricity. So that has reduced our carbon dioxide emissions in half since the 1990s. Now, on the flip side of that, which we will look at, is that we've also converted our energy profile, to being very dependent on natural gas. And so we will look at the pros and cons of that, but this just gives you the general overview. So let's look at electricity on the next slide. We are looking now at electricity generation, how we get that flow of electrons to occur. And the example that we're going to use is coal, but we can substitute any of the other forms of electricity generation here. But let's look at coal first. So the coal is rock that is pulverized and then burned in a boiler. And as it's as it's burned, cool water that's brought into the boiler is heated, creating steam. The steam rises and displaces the steam ahead of it and causes this flow of steam to turn a turbine. A turbine is a series of blades, almost like a fan, but not exactly. You can see they start from a a larger rotor to smaller and smaller rotors turning in this turbine. And as you get from the larger gears to the smaller gears, the speed becomes increased tremendously, and that allows the generator to produce a spark of electricity, which then begins the flow of electricity and moves it down the power line, transmission line. So you can see in the example here for coal, there is ash produced as an end product, and that does need to be moved to a landfill. And you can also see that the water is returned in a form of warmer waters. It's being returned to the environment. And that changes the habitat where the warmer water is being released. And as we've discussed before, organisms such as fish are very sensitive to temperature. And some may not be able to survive in warmer water. It might also bring in species that were not originally there that prefer warmer water. I also want to point out that the coal and the water that's being used to turn the turbine do not come into contact with one another. So let's substitute here in this diagram nuclear energy, which we'll look at in more detail later. But the nuclear energy is contained within a structure, the nuclear reactor, and it too it heats water, which creates steam, which turns a turbine and generates the electricity. The difference there would be with a nuclear reactor, the spent nuclear fuel rods are what we need to remove and store as opposed to ash. So there are some considerations, serious considerations with that. We could also substitute here in this diagram for a wind turbine, for example. And in a wind turbine, we skip this whole left half of the diagram and go directly to the turbine turning. So the blades of the wind turbine are what turn the gears, which generates the electricity. Same with hydroelectric. The water flow turns the turbine. So it too skips this whole left half of the process. All right, so looking now at the fuels that are used to generate electricity in the United States, you can see that when this was published, 2012, we were reliant on almost 50% being coal to generate electricity and almost 25% being natural gas, and overall about 70% being fossil fuel. So these numbers have shifted around a little bit, but the way they have shifted is that the use of natural gas has increased and moved up this way. The use of coal has shrunk. The use of nuclear fuels has also shrunk. And some of the renewable energy sources have increased in numbers. Now, you don't need to know the specific numbers here, but I want you to understand that we still have a significant reliance. A main reliance is on fossil fuels, and we'll look at the pros and cons, particularly of natural gas, which has become the more dominant fossil fuel use. Okay, and this is true globally. Fossil fuels provide most of the world's energy, but there are limited supplies, so that's one of several reasons we need to look at energy conservation. The other reason is that two other reasons. Energy consumption is increasing globally. If you read the case study in the textbook, you saw about the use of gasoline in China and how that's increased. And the other thing is that there are pollutants which result from the generation and use of fossil fuels. And so that's why we need to look at limiting these issues. So one of the means to do that is to increase energy efficiency. So first we have a definition. Energy efficiency is the ratio of the total work done to the total amount of energy introduced into a system. So when we look at the efficiency of sources of electricity generation, primary sources, we see that coal burning plants are only about 35% efficient. Natural gas burning power plants are closer to 60%. So that would be an energy efficiency savings. And we can also look at the efficiency of electricity transport. And we can really look, and there's been a lot of consumer demand for improving the efficiency of devices that use electricity. So that might be everything from a vehicle, a car, to a washing machine, to, if you're a business, the devices that use electricity in your business. Everything from the lighting to some manufacturing equipment. So all of these combined work and have been improved upon over the last several decades, but we still need to continue to do that work. Okay, so that's going to be a wrap for this screencast, and next we'll look at the various advantages and disadvantages of each of the primary fuel types.